Hello, scholars. In this lesson, we're going to learn just a little bit about my favorite club. It's called IUPAC, the International Union of Pure and Applied Chemistry. And I have to introduce them because they have written all of the rules about chemistry that you've been learning about this year, both tacitly and explicitly. So we do have some homework associated with this lesson. It looks like there are several questions. It looks like quite a lot. But when you really learn to name ionic compounds, you'll find that the more you name, the faster you get at it, and that even if we do a ton of questions, it may not take you that long. So please write these questions down at the very beginning of the classwork page that you write in your notes tonight, and then follow it with this aim: how do you name ions and ionic compounds? And then this do now, which looks simple enough, but we'll really get to starting it tomorrow. Okay, so IUPAC, it was formed not that long ago, in 1919. This was the year, it was a very important year. We were leading up to World War I. This was the year that women in America won the right to vote, and it was also the year that IUPAC was formed. Basically, it's a group of chemists, but and they're international, as the name would apply, but they make all the rules for chemistry. They standardize all the names. As you can imagine, prior to their existence, naming compounds would have been different in different countries and in different languages. So basically now all scientists in the world adhere to IUPAC standards. So when an ion is positive or negative, it just has to do with whether it has gained or lost electrons. And the positive ions are usually the metals. Hydrogen is another one that can be positive, even though it's a nonmetal. And when we name them, the ion at least, we really just say the name of the element and then say the word ion at the end. If the metal happens to be a transition metal, however, then you would need to include its Roman numeral. Negative ions are a little bit different. As you may remember from our last lesson, negative ions are named by dropping the last few letters of their element name and replacing it with a suffix, IDE, or "ide." So that's how you name the ions. It's really not that difficult. Just remember, if it's positive, it's basically the same name with the word ion in the end, and if it's negative, you'll have to end it in "ide." So what does binary compound mean? A binary compound would be a compound that has two different elements, but a binary ionic compound would be one that has two different ionic elements. I just threw a couple of examples in there to clarify that. This guy's molecular, so it wouldn't qualify to be ionic, of course, but it does have two elements, so this would be a binary covalent compound. And then here's my binary ionic compound example, but it's not the only one. Just as a sort of different example, how about calcium oxide or aluminum chloride? All of those would be binary because they contain two different elements. And this one might be interesting because I think some of you might think it weren't binary, but it's not that you are required to have only two atoms. It's that you're required to have two elements. So if we have aluminum, the first element, and chlorine, the second element, then it's binary. So when we name these guys, it's really simple. You probably heard me doing it just now, but you name the positive ion, which is just in this case aluminum, and then you name the second, the negative ion, and in this case it's chloride. So this one's aluminum chloride. This would be calcium oxide. This would be sodium chloride. For molecular compounds, this is not the case. You don't name them that way. So I'm not even going to talk about that right now. But these ionic compounds, it's just sodium chloride, calcium oxide, aluminum chloride. You just say the names of the elements next to each other. Now, if you have a polyatomic ion, it actually is very similar, but let me get you started with some of the background. So polyatomic ions are on table E, as I'm sure you remember, and most of them are negative, or they're anions, you might remember that word. But there are a couple of examples. We have ammonium and hydronium, and even dimercury too. So if the compound contains a polyatomic ion and the positive ion is a metal, then you really just need to name the metal ion and then write the word of the polyatomic ion's name. So in the case of this guy, KNO3, it would literally just be potassium, which is the name of the positive ion at the beginning of the compound, and then nitrate, which perhaps you haven't memorized that yet, but it's on table E, so you can go look for the NO3 on table E. So let's say, for instance, that the compound is like this one, where you have your polyatomic ion at the beginning of the compound. That's our ammonium ion. Then in that case, you just need to name the positive ion, whatever it is, from table E, so ammonium, and then you would name the negative ion with an IDE at the end. And then lastly, you're in great luck if you're naming a polyatomic ion compound that has two polyatomic ions, because then you don't have to do anything other than name the ions right next to each other. So in this guy's case, it's ammonium nitrate. All right, so we're going to do some practice here. I'm going to fill in several of these and then discuss them with you. And I'll leave one or two blank and ask you to answer them in Edpuzzle. So here's my first example. LiF, the positive ion, is Li+. It's the positive ion's always written first. And then we have the F-, which is the fluoride. And then when you name this, we're just pretty much stitching them together, so lithium fluoride would be the answer. I'm going to work backwards for this one. So I put in the positive aluminum ion and the nitride ion with their charges, because that's going to help reveal to me what the formula should be. And I'm thinking that since it's ionic, we need to write it empirically. So instead of Al3N3, I'm going to write ALN. Very simple. All right, let's do the next one. So basically, we have the magnesium ion first, the bromide second, so the name is just magnesium bromide. All right, we're going to work backwards from aluminum oxide. So we have our aluminum ion, which is +3, and our oxide ion, which is -2. You would need to cross those charges to make the formula, so it's going to be Al2O3. So for NaBr, we have our sodium ion, bromide ion, and the name, of course, would just be sodium bromide. All right, calcium iodide, let's work backwards. Here's our negative ion, iodide, and calcium ion, and we're going to cross the charges for that, so it's going to be CaI2. For CuCl, we're going to work forwards. Based on the subscripts, the invisible subscripts of 1 and 1, I know that the chloride's charge is -1, but that was never a surprise. The thing that's tricky is the copper ion, because it's a transition metal and could have many different charges, but in this case it's going to be getting a charge of 1. So I'll write that in now. And we can also write the formula from here. Remember to include Roman numerals in the name of a compound containing a transition metal. So in this case, copper-1 chloride would be the official IUPAC name. All right, iron 2 sulfide. Sulfide is always a -2, but iron is a transition metal and has more than one option. Thankfully, IUPAC told me that it has to be an iron +2 ion based on the name. And then we would cross the charges and simplify for the formula. So it's just going to come out as FeS, even if you thought it might be Fe2S2 at first. All right, so tin is a transition metal, and it could be more than one charge. We're going to rely on charge crossing to figure out what the subscript is. So hydroxide is our negative ion, and I checked table E, and its charge is -1. So that means that the kind of tin that we have is going to be based on its charge and the fact that you have 2 hydroxides in the compound. So that 2 you can sort of uncross and bring up here, and that's going to tell you that the kind of tin that we have must be tin 2 in order to balance the charge of 2 separate hydroxide ions. So we have the name now as well. This would be tin 2 hydroxide. Copper 2 nitrate. Nitrate is on table E. Its formula is NO3, and its charge is a -1. And they told me in the name that the kind of copper that we're dealing with is a +2 type. And we can cross the charges to make the formula. I know that this Cu is going to have a subscript of 1 because it's coming from the charge on nitrate. But the charge on copper will come down and be the subscript for nitrate. So that means that after I write the NO3, I'm going to realize that I need 2 of them, and I'm also going to add parentheses. All right, so we've reached the pair up. Please copy down these questions, and we'll answer them in class next time I see you. And also copy down this summary. There are some formatting issues, like here and here, and I'm going to trust that you'll be able to correct those. All right, don't answer these, just copy them down on your classwork page. Thanks for watching.